Okay, I proved the equation of velocity for accelerated motion. Okay, I would like to switch to mathematics to discuss velocity equation. We call this equation V equal to AT plus V0. If you remember from mathematics, we have equation of line. The equation of a straight line in mathematics is y equal to mx plus b. This is equation of line. And you know here, we have some definitions here. X, it is called independent variable. Y, it is called dependent variable. If you remember, M, it is called a slope. And B, called intercept. If I want to plot this line on a coordinate mathematics, you can do it like this. Independent variable should be horizontal axis. That's X. Dependent variable should be vertical. Therefore, you have XY coordinate here. Okay. You can plot this line like this. Therefore, the equation is y equal to mx y equal to mx plus b. According to this definition, b is intercept. It is here. This is b. And you know a slope is rise over run, which is here. This is the slope, rise over run, which is m. And you have two variables. The first variable is x, and the second variable is y. Okay. If you have positive slope, in other words, m is positive. If m is positive, if m is higher than 0, therefore your graph should be ascending, or you have ascending graph. If m is negative, less than 0, you have a descending graph. And if m is 0, means there is no slope. Okay. Now, let's switch to physics. In physics, you can have this comparison. Okay, in mathematics, we have y equal to mx plus b. But what do I have in physics? I have v equation or velocity equation. What is velocity equation? That's v equal to at plus v0. If you compare between these two equations, you can figure out that t, it is similar to x. Therefore, it is independent variable. Similarly, v, it is dependent variable. v0, it is similar to b. That's intercept. Or initial velocity is intercept on your graph. And acceleration a is a slope. Consequently, you can have this justification here. Therefore, I can plot it. As I told you, independent variable is should be horizontal, t. Dependent variable, which is here, it should be v. And you can plot it. And of course, a velocity equation on the coordinate is a line. In other words, the v equation or velocity equation is equation of line on the coordinate. Therefore, you can plot it. According to this graph, the slope or rise over run is acceleration of the particle. A is equal to A, acceleration. Here, if you look at this intercept, I told you V0 is intercept here. Therefore, you have this intercept here, V0. And of course, you have this straight line on the coordinate. You have similar discussion here. If, for example, you have positive slope, imagine A is higher than 0 or positive, of course, you have ascending graph. And if you have ascending graph, okay, remember this point from previous lecture, that if you have positive acceleration, what happens? If you have positive acceleration, you have increasing velocity. Of course, it's equal to ascending graph. Therefore, it is increasing velocity. Next one is negative acceleration. So you have decreasing velocity. Let me show it to you. This is T. This is V. If you have positive acceleration, you have increasing velocity, or you have ascending graph. Look at this graph. This is increasing velocity, or A is positive. It's here. This is first case. Similarly, if you have negative acceleration, it's similar to mathematics. You have a descending graph. Okay, so let's plot it. Okay. Independent variable is t. V should be vertical. And here you have decreasing velocity, which is here. Therefore, look at this one, from here to here, it is V0. From here to here, it is V0, initial velocity. But here, A is negative. Therefore, you have decreasing velocity. Okay, now, listen to me carefully, please. It's possible to prove this point in physics, but it is not the scope of this course, but we need the final result in order to show you other equations for accelerated motion here. So you should memorize this point in physics, but it can be proved. I'm telling you, it can be proved. But imagine at first you have graph of acceleration. The graph of acceleration. If I have graph of acceleration, the area under the graph of acceleration is velocity of the particle. It can be proved, but you don't have to prove it. Just use the result. Therefore, here you have velocity. So you have graph of velocity. If you have graph of velocity, the area under graph of velocity, it is a displacement. Therefore, we need this point here. Just use this point. Just memorize it. Important. I will use it here. Okay. If I have velocity graph, and I already have it because it's here. I already have this graph here. Okay, let me use it here. I'm going to show it to you. Okay. And pay attention, you don't have to learn this part, but you have to learn the final result. But I want to prove this analysis here in order to show you the final equation. But we need it here. Okay, what did I tell you? If you have a graph of velocity, which is here, this is graph of velocity. That's a straight line, and it has a slope. Okay, if you calculate the area under this graph, it is here. I'm going to show it to you. I'm talking about this area here, the area under this line. In order to calculate this area, I can divide it to two parts. The first one is rectangle at the bottom. It is here. And the second area is triangle on the top, which is here. In other words, the area under this graph is the area of the green part plus the area of the purple part. What is the area of green part? You know, this is T, this is V0, because this is intercept here. Therefore, area of this part, only this part, it is V0T. The area of rectangle is this length times this length. That's V0T. The area of this triangle here, the top part, it is, you know, it is this length times this length over 2. This is the area of the triangle. Let's do it. What is this length? Of course, it is T. Therefore, T times. What is this length? Of course, it is from here to here, see? From here to here, it is V. From here to here, it is V0. Therefore, the whole part, this part, it is V minus V0, only this part. That's difference between V and V0. That's only difference for the small part on the top. Therefore, you want to use it. Consequently, it is V minus V0. And you know V minus V0 according to, look at this one, please. A equal to V minus V0 over T. This is equation of acceleration or definition of acceleration. Therefore, V minus V0 equal to AT. Therefore, this part is AT. Because I want to use it here. Okay, this length times this length divided by 2. It's here. Therefore, it is half AT times T. It is AT square. Therefore, area of the purple one is half AT square. Area of the green part is V0T. Therefore, the whole area, total area, it is the green part V0T plus area of purple part. It is half AT square. And I told you, this area under the graph of velocity should be displacement, which is x. Therefore, x equal to half AT square plus V0t. Very important. Pay attention. You should learn only this part. This part here, this part, it is only for your information. But we need only final results. I proved it in order to complete every analysis here, but you don't have to use this analysis here. Just use the result of this analysis, which is displacement. And I want to talk about this equation. This is displacement equation. What is V0? You know, it is initial velocity. What is T? It is time, and it is in seconds. And unit of initial velocity is meter per second. A is acceleration of your moving particle. That's meter per second square. And X is displacement traveled by your particle from the beginning. It is in meters. Consequently, based on this equation, you can calculate the displacement traveled by your moving particle, which has acceleration. This is second equation of accelerated motion. Very important. Pay attention. You have to use only the result. And we need it for many problems. Okay. Let's have some examples. Example. There is a particle which has acceleration of 2.5 meter per second square. And you know, it is positive. It means you have increasing velocity. If initial velocity of your particle, it means velocity at the beginning, it is 1 meter per second. After 10 seconds, what is the displacement traveled by this particle? What is X value? Just for information, instead of X, you can use D. Therefore, you can have this equation, and that's completely right. D equal to half a t squared plus V0t. This is second form of this equation. Okay, just follow this equation here. X equal to half a t squared plus V0t. So X equal to half. A is 2.5. Time, it's given, that's 10. It is 10 square. Plus V0, it is 1 meter per second times 10. You know 10 square is 100. There it is half times 2.5 times 100. 1 times 10 is 10. Therefore, if you calculate this part, it is 2, see, this one and this one will be cancelled, which is 50. Therefore, here, that's 125 plus 10 is 135 meters. Answer of the problem is X equal to 135 meters. It means after 10 seconds, it traveled 135 meters for your particle. Next example. There is a moving particle. It has acceleration of 4.2 meter per second square. The initial velocity of this particle, V0, is I'm sorry, V0, we don't have it. We don't have V0. We can observe that after 5 seconds, the particle travels, x is 200 meters. If you have this condition, what is V0? What is initial velocity of your particle? Okay, according to this information, so you have x, displacement, you have time, and you have acceleration. If you have this information, it means you should use x equation. Therefore, x equal to half a t square plus V0t. Therefore, x is 200, plug it. Half, you have a value, 4.2. T time is 5 square plus V0, we don't know, times 5. You know, 5 square is 25. Therefore, here, find this part, 200 equal to 1.7, 2.1 times, that's 52. Sorry, 52.5 plus 5 V0. So 5 V0 equal to, it is 147.5. And from here, find V0. It is 147.5 over 5. Therefore, V0 equal to 29.5 meter per second. Answer of the question. Okay, I recommend you to practice these problems by yourself. So it's very important. Thank you.